Good morning, everyone. This is Meeka Raji from Indian Institute of Science Education and Research, Trivandrum, India. On behalf of Dr. Ruba Kumar, I am going to deliver a talk about the topic, the emergence of SARS-CoV-2 variant of concern Omicron, biological features and genomic concern. The outline of the presentation is as follows. The variant of concern and variant of interest of SARS-CoV-2, variant of concern Omicron and its features, pathogenesis of Omicron and standard detection, prevention measures, vaccinations. As we all know, coronavirus infection caused by SARS-CoV-2 virus is a worldwide health threat that has infected a substantial portion of the world population in a short period of time. It is a natural tendency of a virus to change its genetic makeup through point mutation, and such viruses with new mutations are called variants of the original virus. Likely, SARS-CoV-2 also undergo mutations over time and resulted in the accumulation of number of new variants in the environment. Among these new variants, closely similar variants are categorized into major clades or subtypes, that is a group of organisms that originate from a common ancestor, namely L, V, S, G, GH, GR, GV, GRY, and O, as per the Global Initiative on Sharing or Influencer Data Nomenclature System or GISAID system. According to a difference in virulence, transmissibility, pathogenicity, and vaccine efficacy of these variants, they are mainly classified into two categories called variants of interest and variants of concern. A variant of interest is the one that possesses mutations that are suspected or known to cause significant alteration and is widely distributed. If a variant of interest is known to spread more quickly or cause more severe disease or escape body's immune response or reduce effectiveness of available tools such as public health measures, treatments, diagnostics, and vaccines, it becomes a variant of concern. The variant of concern of SARS-CoV-2 include alpha, beta, gamma, delta, and omicron. These variants are more likely to cause severe disease and can remain undetected and are able to resist antiviral treatment. One of the latest variant of concern of SARS-CoV-2 that has recently emerged as a global distress to more than 115 countries is Omicron. The number of mutations that this variant has undergone make it so concerning. 15 mutations itself reported in the receptor binding domain of spike protein Omicron. It is found that the amino acid mutation in spike proteins and other structural protein mutations such as mutation membrane protein, envelope protein, nucleocapsid protein made Omicron unique from other variants of concern. These 15 mutations present in Omicron spike protein are uncommon among other variants of concern on comparing. Here you can see an overview of the evolution of different variants of concern of Omicron and other variants of SARS-CoV-2 and their subtypes or clades in which they are included. In this particular image, amino acid changes to spike protein in SARS-CoV-2 variants of concern is presented. Throughout its genome, the Omicron variant possesses at least 50 mutations that differentiate it from SARS-CoV-2 reference strain. Around 30 of these occur in the S gene, and some of which overlap with mutations that were previously identified in other variants of concern, such as alpha, beta, gamma, and delta, and as well as number of mutations that are considered to be unique to Omicron at this step. Moving on. In this table, you can see some of the important mutations that made these variants of concern different from other variants of SARS-CoV-2. As you can see, the important mutation in the amino acids of alpha variant include 69 to 70 deletion, N501Y, P681H, etc. Included in the list is a trio of mutations that have raised alarm bells in other variants of concern. That is, a lysine to asparagine substitution at position 417, that is K417N, and a glutamic acid to lysine substitution at position 484, that is E484K, and an asparagine to tyrosine substitution at position 501, that is N501. This N501Y, which Omicron has in common with alpha, beta, and gamma, is particularly noteworthy mutation, even by itself, since it has been shown to increase binding capacity to human receptors and is linked to increased infection and transmission. So together, these three mutations have been shown to induce relatively high conformational changes in spike protein and facilitate immune escape. Beta and gamma possess all three of these mutations, while delta have only K417N mutation. And as well as an additional RBD mutation in delta is a 300 license substitution at 478 position, that is T478K. It is so from this we can say that the Omicron's new and astonishing capabilities came from these modifications in its anatomy. The Omicron variant possesses around 11 additional receptor binding domain mutations that are under investigation. One of these, a glutamine to arginine substituent at position 498, that is Q498R, has been shown to increase ACA2 binding affinity more than 1000-fold in combination with N501Y mutation. So moving on to the pathogenesis and antibody load. Omicron has an unprecedented capacity to hide from the immune system compared to other variants. During infection, fish-shaped clumps of amino acid-tamed receptor binding domain atop the coronavirus spike grasp onto a protein onto the exterior of some human cells called ACE2 receptor. To get inside a cell, older virus variants need two proteins called ACE2 and TMPRSS2. Whereas Omicron need only ACE2 to get inside the cell and make cells without TMPRSS2 vulnerable to infection. The variant is then enclosed in an endosome, which wanders into a cell before breaking free. This unique ability enabled Omicron to infect a large number of cells that lack the surface protein TMPRSS2. To prevent this, the immune system produces antibodies generated by earlier infection or immunization. And in this graph next to this image, you can see an overview of how levels of virus, antigen, and antibodies change over time during a COVID-19 infection. Here you can see the role played by antibodies, IgG, IgM, and other viral antigens and viral amines. So, moving on to the molecular detection. The reverse transcriptive polymerase chain reaction is the gold standard and widely accepted method for SARS-CoV-2 variant, including Omicron. To verify the presence of the virus, the approach used to look for specific gene amplifications such as S gene or spike gene, enveloped gene or E gene, and nucleocapsid gene or N gene. However, since the S gene has been highly altered in Omicron, many available primers may produce results indicating the absence of S gene or S gene dropout. In combination with the detection of other viral genes, this S gene dropout could be utilized to diagnose Omicron, and however, genomic sequencing is necessary to confirm the presence of Omicron variant. So, as we all know, the symptoms of Omicron include headache, cough, shortness of breath, fever, fatigue, sore throat, or muscle or body aches, and loss of taste or smell, and it is mostly transmit from one person to other very fastly. So another thing to consider about Omicron is it's more likely to reinfect people due to its rapid transmission state. So we people try to develop a lot of vaccines to eradicate Omicron from our environment. And several studies have reported that existing COVID-19 vaccines such as Pfizer, AstraZeneca, Johnson & Johnson, Moderna, and Novavax show reduced efficacy against these latest variants of concern Omicron. While our current mRNA vaccine still provides some protection against Omicron. So according to the preliminary findings, people who get a booster or a third vaccine dosage may be better protected than others. Even if the COVID-19 vaccine do not give 100% protection against new variant, each of them can decrease the illness and death rates up to a certain extent. As a result, encouraging vaccines, boosters, and accessible testing and maintaining hygiene and social distancing, self-quarantine, and safe discharge of biological materials will play a critical role in preventing disease spread and quickly detecting outbreaks. However, people who have received their COVID-19 immunization and are exposed to COVID-19 are less likely to suffer severe illness than those who have not received their COVID-19 vaccine and exposed to COVID-19. So moving on, here you can see the origin of different variants of concerns of SARS-CoV-2 along with a comparison between the 5 variants of concerns of SARS-CoV-2, alpha, beta, gamma, delta, and Omicron. From this comparison, it is clear that how dangerous Omicron with respect to other variants of concern. As we all say, prevention is much better than cure. So, protect yourself from coronavirus and slow the spread and be vaccinated. So, thank you, Nikalaji.